HIMO 2. Now, the advantage it had over its predecessor was bifacial. It was bifacial, right? So it was having bifacial, it was using bifacial parc technology, and it had glass-to-glass encapsulation. In May 2018, we came up with HIMO 3. It was having all the benefits of its predecessors, plus the benefit of using a half-cut cell, right? So we will discuss each of these things like the parc technology, because many people are asking about the basics of the parc technology and the bifacial thing and everything. So we will, in coming slides, we will discuss each one of them. What is the benefit of using half-cut technology and everything. Our latest offering, which was offered in May 2019, is HIMO 4. Now, it has all the advantages of its predecessors, like it is available in monofacial and bifacial. It has the half-cut. It is using a split cell technology. It is having the advanced parc technology. And to add to it, it has M6 wafer, which is the bigger wafer. Earlier, we were using a 158 mm wafer. Now we are using a 166 mm wafer. So what are the advantages of using this bigger wafer? We will see now. So if I have to sum up the advantages for the customer, I'll put it like, since we have improved in the cell manufacturing process and the efficiency is improved, our process too has improved. Our process of making the module has also improved, and that has resulted in the decreased BOM cost because of our experiences and our lesser change requirements in using the 166 mm wafer. So it will clearly reflect on the overall BOM cost. And then this cost, this benefit will be reflected to the customer in the price that we offer to them. The another benefit of using bigger cell is that there will be a lot of saving in the BOS. Since from HIMO 3 to HIMO 4, the voltage of the module has not, the VOC of the module has not changed. So the string length is same, but the power output from the same string length has increased. So we need lesser pile foundations, we need lesser cable, lesser labor cost is required less. So all these benefits will be highly reflected in the BOS savings. Right. Our module is capable of being installed at all the trackers too, and the input current matches exactly with the string inverters. Now, this is the bifacial module. The bifacial module, the backside has no C-frame design. And because of no C-frame design, there will be no hotspot because of these frames. We use 2 mm cells in front and back in a bifacial module. In a monofacial module, we use 3.2 mm glass. The bifaciality is also wonderful. It's glazing 75%, and they are adequate mounting holes so that these modules can be installed anywhere with any tracker application. We are currently offering this thing in 6 bus bar, and soon we are coming it with 9 bus bars too. We'll also see the benefits of the various things that we have used in our module in the coming slides. One more thing, the efficiency of our module is wonderful. It is at 20.9%, and we have adequate capacity for you guys. So all your needs will be satisfied. So we will discuss the benefits of HIMO 4 in 4 parts. Now, our module has excellent power generation performance. Now, why it is getting those, what are the parameters that are enabling our module to get this excellent power generation performance? The next thing will be reliable bifacial gain. So I'll start with the basic, what is a bifacial module, what is the structural change in a bifacial module, and how we are achieving the reliable bifacial gain, what are the factors affecting the bifacial gain. The third thing we will discuss is the reduced BOS cost, how the BOS cost has reduced, what are the enabling factors which are helping us to reduce the BOS cost, eventually the customer to reduce the BOS cost. The fourth thing, and one of the best things about our module is the leading power and quality warranty that is the lowest in the industry. the best in the industry actually. The degradation is the lowest in the industry, and our module is offering the best degradation in the industry. Now, this module has 6 bus bars, and we are coming with 9 bus bars soon. So what are the benefits of having more bus bars? Now, more doesn't mean that you cover whole the cell with bus bars, but optimizing it, we have, after our optimization calculations, we have come up with the 6 bus bars and 9 bus bars soon. So 6 bus bars, if you have the more bus bars, then what happens is that the electron or the charge carrier, which is generated at the far end of the cell, has the chance to find this highway of ribbon, and it has the chance to contribute to the current because of lesser internal resistance it faces. So because of lesser internal resistance, there will be more current that will be produced by the cell. Now, in the 9 bus bars, we have increased our bus bars, but at the same time, we have reduced the width of the bus bar. So the side which is facing the sun, the area which is facing the sun, is not decreased. We have done some careful optimizations, and we have gone through various tests that the amount of the area that is facing, that the cell is facing towards the sun, it is not being reduced at any point of time. Another thing that we have added in it is that instead of using a flat ribbon, we are using a circular ribbon. Now, because of this change, what we have done is that, because of the change that we have done is that the light which is falling on the surface is getting reflected back to the surface of the cell. The light which was falling on the bus bar is getting reflected, and it is being reflected back at the cell. Because of this technical advancement, the wattage of the module has considerably increased. Another benefit of using more bus bars is that the efficiency of the module the mechanical ability of the module increases. The efficiency definitely has increased. The mechanical ability of the cell has increased. So I have just covered all these points, that the internal resistance has decreased, and the ability of the mechanical ability of the cell has increased. Now, we proudly say that our module has the lowest LID. Right. So we will first discuss that what LID is, what parc technology is, what are their benefits, and what are the changes we have done in our module to encounter the LID problem. Right. So we will first discuss what is parc. The parc is passivated emitter rear contact technology. So to understand the parc, so that everybody can understand, I'll just start from the very, very basic. Now, what happens, in the left side, you have the diagram of a conventional cell, and the right side, you have the parc cell. So in conventional cell, what happens? The light is coming, the energy photon is coming from the top side. It passes through the emitter region or the N layer, and then it enters in the depletion region, and it liberates an electron and a hole pair. Right? The electrons, the charge carrier, will move upwards and the hole downwards. Now, what happens is that not all the photon which is coming from the sun follows this path. It happens all the time, so we can't say many, but many times what happens is that the photon which is coming from the sun passes through the N layer, passes through the depletion layer, passes through the whole base layer, and just comes to the aluminum metallization without doing any effective work, without imparting its energy in the depletion region. So this photon which has fallen on the surface of the module still got wasted, because it just came and it passed through all these layers and it entered the aluminum metallization. So we should find some way that this photon which is coming from the sun gets at least a second chance of providing its energy into the depletion region. So what we have done, we have come up with a dielectric perk layer which is just above the aluminium metallization, right? And it is in the lower half of the base layer. So now what happens is that the photon is coming from the sun. If it has passed through the N layer, depletion region, and the base layer, it will have a chance, there is a chance that it gets reflected because of this electric perk layer goes into the depletion region. So it gets a second chance of giving its power in the depletion region and contributing to the current. This is one of the benefit of perk. Another benefit of adding this perk layer, dielectric perk layer, is that the electron which is generated at the far end, like the electron which is generated in this near this aluminum metallization, they have the tendency to directly jump into the aluminum metallization without going towards the emitter region and the bus bar, right? So instead of going up, they just jump in the aluminum metallization. And this is called recombination. So if we have added a dielectric perk layer, that electron will not jump into the aluminum metallization and it will travel the path, right? So if you sum up these benefits, one is the reduction in this recombination, and the electron gets a second chance to move upwards and to contribute into the current. So the benefit of perk technology is very much visible in the infrared end of spectrum, when the wavelength of light is between 1000 to 1118 nanometer, right? So this is normally in dawn and dusk. So it has two things. First of all, it improves the cell efficiency because this aluminum metallization layer is not getting heated up. The second thing is that recombination is reduced, right? So it is actually acting as a shield. So this was about the perk technology. The next thing is the light-induced degradation. So what actually is light-induced degradation? We will just go step by step. What is this problem? So if we go by the definition, when the solar panel faces the light for the first time, there is a change in the Fermi energy level of the module, and because of which the efficiency of the module decreases. So I'll put it in another way. When the solar module first faces the sunlight, its efficiency decreases. And why it decreases? Because of the change in the Fermi energy level. Now, why this Fermi energy level is changing when the module is first exposed to light? The chemical change which is enabling this Fermi energy level change is that there is a boron-oxygen complex which is formed in the module. And because of this, the Fermi energy level changes. Now, why this boron and oxygen complex is formed? From where did boron came and from where did oxygen came? So boron is utilized as a dopant while we make the p-type material. In the very first initial process, during the Caesar process, we add boron to it, right? And oxygen was also utilized in heavy concentrations in the Caesar process. So boron and oxygen both are present in the cell. And when the light first falls on the module surface, these boron-oxygen makes a complex. Now, these boron and oxygen complex, it acts as an intermediate energy level. Now, what happens because of these intermediate energy levels is that the charge carriers which are liberated, they are trapped by these boron-oxygen complexes. And the charge carrier just gives up its energy in the form of heat in the boron-oxygen complex and without doing any useful work. So, because of this boron-oxygen complex, the efficiency of the module decreases. right? So what should we do to reduce this boron and oxygen complex formation? We have to either reduce the boron, we have to either eliminate the boron or the oxygen. Now, oxygen, because we follow Caesar process in the manufacturing of monocrystalline module, oxygen cannot be removed. So boron can be removed. So instead of using, in Longi solar modules, very proudly say that instead of using boron as a dopant, we are using gallium as a dopant. This is one of our patented technology. And you must have seen the PV magazines. It was in the news also that we have patented this technology of using gallium as a dopant. So no boron, no boron oxygen complex formation, and no LID loss. Still, there will be LID loss in the module, but very less. And we very proudly say that the LID loss is the least in our modules. It's only 1.5%. Also, ELE degradation is least in Longi solar modules. You can compare all the modules and you'll find that the LID is least in Longi solar modules. So without wasting much of our time, we'll move to another benefit of Longi solar module. We use half-cut technology. Majority of the players are also using half-cut technology. So I'll just introduce you what are the benefits of using the half-cut technology. You know, the equation of power loss is equals